Hello everyone. I am Ashish Kumar Prasad and today I am going to discuss about solving linear system using LU decomposition method. So in first two lectures I have covered how we can decompose a matrix A as a product of lower triangular and upper triangular matrices. Now I will start with one example and I will show how we can use LU decomposition in order to solve a linear system. So let us take one example. See, my question is solve the following system. Solve the following system using LU decomposition method. So my matrix is here. First of all, I will write my equations 2x1 plus x2 plus 3x3 is equal to minus 1. Next equation is 4x1 plus x2 plus 7x3 and that is equal to 5. And finally, I write minus 6x1 minus 2x2 minus 12x3 and that is equal to minus 2. So I have to solve this system of equations using LU decomposition. So first of all, I will write this system as a product of lower triangular and upper triangular matrices, right? So first of all, I will write the system and then I will apply forward substitution as well as backward substitution method to arrive at our answer. So first of all, let us have a look at the methodology, how we can implement LU decomposition method. So suppose I write the system in the form of AX equal to B. Suppose, if possible, I will decompose A as a product of L, where L stands for lower triangular matrix, and U, where U stands for upper triangular matrix. Then, when I substitute A equal to LU, then I will get LUX equal to B. Now, I will do one more substitution. I will assume that ux is equal to y. And with this assumption, my equation number 1 will become ly is equal to b. So first of all, I will solve my equation number 2 because L is known quantity, B is known quantity, and here Y is unknown, right? Y is your unknown. So I will solve it for Y and I will substitute the value of Y in Ux is equal to Y and finally I solve it for X. So I will substitute the value of Y obtained from equation number 2 obtained from equation number 2 to the equation ux equal to y, and I will solve it for x. And finally, solve it for x. So this is the way in which I will solve the linear system represented by matrix equation Ax equal to b using LU decomposition method. So there are three steps which is involved here. First of all, you can see my steps which are involved here are, first of all, I will write A is equal to LU. Means I will write or I will decompose A as a product of lower and upper triangular matrix. So my first step is find LU decomposition of A. LU decomposition of A. Second thing, once this is there, see here, I will solve the equation Ly equal to B for y, and this is done by forward substitution. So I will write here the second step as solve Ly equal to B by forward substitution. By forward substitution. And the final step is that to solve the equation ux equal to y, then I will solve the equation ux is equal to y by backward substitution to get x, by backward substitution to get x. So these three steps are important. We will perform LU decomposition in these three steps. Now let us have a look how we can solve this equation. See here, first of all, I will write my system in the form of Ax equal to B. So the system can be written as, first I write the coefficient matrix 2, 1, 3, 4, 1, 7, minus 6, minus 2, minus 12. And x is my x1, x2, x3. So I write x1, x2, x3. And my b is, the right hand side is minus 1, 5, minus 2. So here you can see that this is my A, this is my X, and this is my B. So I am able to write my equation in the form Ax equal to B, where A is given by this matrix, X is given by x1, x2, x3, and B is given by minus 1, 5, minus 2. So once you write this, I am interested in decomposing A into the product of lower and upper triangular matrix. And we will keep care that whenever I am writing A as a product of L and U, I will use ones on the diagonals of L. So first of all, I will start with A, 2, 1, 3, 4, 1, 7, minus 6, minus 2, minus 12. And you can see I will try to row reduce it and I will try to get U. And at the same time, I am trying to get my L. L is 1, 0, 0. Here 1, 0, here 1. Remaining elements I will try to find out. So what is my first operation? See, in first column I will try to bring the elements 4 and minus 6 to 0. I will try to make these positions 0, and for that I will multiply minus 2 to first row and I will add it to second row. So let us see what I am going to get. I am going to get 213 minus 4 plus 4 0, minus 2 into 1 is minus 2 plus 1 is minus 1, minus 2 into 3 is minus 6 plus 7, that is 1. At the same time, I want to bring my 3 1 position as 0. So I will multiply 3 to first row and I will add it to third row. So I will multiply 3. So 3 2 is 6 minus 6. I am getting 0. Then 3 1 is 3 minus 2 is 1. And 3 3 is 9 minus 12 is minus 3. So multipliers for this 4 position to make 0 is minus 2 and its negative is 2. So I will put in the corresponding position the negative of the multiplier. And similarly, for making 3 1 position at 0, I have used multiplier 3. So its negative is minus 3. I will put minus 3 in the corresponding position of L. Next target is the element in 3 2 position. For that I will multiply 1. I will multiply 1 to second row and I will add it to third row. So I will get 213 0 minus 1 1, and then 0 minus 1 plus 1 is 0 and 1 minus 3 is minus 2. So multiplier I have used is 1. So its negative I will put in the corresponding position of L. So this is my U and L is given here. So I can write A as the product of L. L is 1 0 0 2 1 0 minus 3 minus 1 1 into U. So U I can write as 213 0 minus 1 1 0 0 minus 2. Okay. Now my intention is to solve the equation Ly equal to B. So L is in my hand, B is also, which is the right hand side. This is my B. So B is also in my hand. So I want to solve the equation Ly equal to B. This is my task. Then I will solve Ux equal to Y. So see, I am writing L as 1 0 0 2 1 0 minus 3 minus 1 1, and right hand side I write augmented B. B is, you can see, minus 1 5 minus 2. I will write minus 1 5 minus 2. So once you write this one, I will row reduce it to find the answer. But here, because you have lower triangular matrix, I will use forward substitution. So let us see how we can implement forward substitution. So first, Y is, I am writing the equations first. The first row will tell you that y1, see, 1 into y1 is y1, 0 y2, 0 y3 equal to minus 1. So y1 I am getting as minus 1. Now second row will tell you 2y1 plus y2, and that is equal to 5. y1 value is minus 1. This is known. I will substitute this value in the second equation. So from that I will get y2. y2 is equal to 5 minus 2y1, but y1 is minus 1, so 5 plus 2, and that is coming to be 7. So y2 value is now 7. Okay. And now once this is obtained, I will jump into the third row. And when I jump into the third row, I will try to find the value of y3. I will try to find the value of y3. So for that, I write the equation minus 3y1 minus 3y1 minus y2 and plus y3, and that is equal to minus 2. So I will substitute the value of y1 and y2 obtained above. You can see I have obtained these two values and I will get the value of y3. So y3 is minus 2 plus 3y1. y1 is minus 1. Then minus y2. If I will bring here, it is plus y2. So y2 is 7. So let us see how much I am getting. Minus 2 minus 3, that is minus 5 plus 7, that is 2. So I got my y. My y is y1, y2, y3. So I will substitute the values and see what is my y. y1 is minus 1, y2 is 7, and y3 is 2. So you can see I have obtained the values of y. So now my intention is to solve the equation ux equal to y for x. So I will write my equation as ux is equal to y. ux is equal to y, and y value I have obtained here. The right hand side is now known. So I will substitute its value and find x, because x is here unknown. So u, first of all, I will see what is my u. 213, I write u is 2130 minus 11, 0 minus 11, and finally 00 minus 2. 00 minus 2. Augmented, the right hand side, y is minus 1, 7, 2. So I write the augmented matrix, and now by back substitution I can find the values of x1, x2, x3. So I will start here from the last line. I will start from the last line. See, if I write the equation 0x1 plus 0x2 minus 2x3 equal to 2. So from this, see, from this I am getting x3 equal to minus 1. From this I am getting x3 equal to minus 1. Now I will jump into the second last equation, which tells minus x2 plus x3 equal to 7. So x3 value I have obtained. So I will write x2 equal to x3 minus 7, and x3 is minus 1. So minus 1 minus 7, and that is minus 8. So I got the value of x2. So x2 is equal to minus 8. And finally, I will jump into the first row and I write the equation. You can see it is 2x1 plus x2 plus 3x3, and that is equal to minus 1. And when I substitute here all the values, I will get the value of x1. So what is x1? See, x1 is equal to minus 1. If I take this to this side, minus x2 minus 3x3, and this 2 is there, so I have to divide it by 2, and I will substitute all the values. So 1 by 2 minus 1 x2 is minus 8, so minus minus plus 8, minus 3, x3 is minus 1. So 8 minus minus plus 3, 8 plus 3, 11 minus 1, 10 by 2, and that is 5. So see what I got. I got my x. X is x1, x2, x3. So what is my x1? x1 is minus 1, x2 is minus 8, and x3 is 5. Okay, so this is my solution, right? So we have to just know at this end that when LU decomposition fails, right? First question is that when LU decomposition fails. So suppose if A is not reducible to, if A is not reducible to U, and if we are using row interchange in order to reduce to U, then your LU decomposition fails. So now I have one interesting question at this end, and you can see that is the question is so that the matrix, so that the matrix, see here 0 1 1 0 has no LU decomposition, has no LU decomposition. This is important question at this end, and you can see here pivot elements are 0. This is the reason behind that. Pivot elements are 0 means the matrix will not have LU decomposition. So first of all, if you want to solve this equation, first of all you write this as the product of L and U. I am writing 0 1 1 0 is equal to CL. So L, what I am taking? I am taking 1 1 ones on the diagonal. Above diagonal elements are 0, right? So I will take here some element. Let us take as A, and I will write U, right? For U, what I will take? I will take here 0, and A I have taken. I can take B, C, D. Okay, so let us see if you multiply these two, what I am going to get. See, if you multiply 1 into B, I am getting B here, and 0 into 0 is 0, and here 1 into C, I get C here, and now I get AB. AB 1 into 0 is 0, and AC plus D. So finally I will write AC plus D. Now you can see here, if you equate the two matrices, if you equate the two matrices, what you are going to get? 0, and here you have B. So in one entry you have in one side you have 0 and other side you have B. So you are going to get B equal to 0. But if you go to 2 1 entry, if you go to 2 1 entry, I have 1 here and here AB. So you can see you have AB is equal to 1. So you can see these two equations cannot be satisfied simultaneously, and hence A cannot be decomposed as a product of L and U. You see B equal to 0, and here what you have, AB equal to 1. So these two equations cannot be satisfied simultaneously. Okay, so this is for today's class, and I request all of you to just subscribe my channel and press bell button so that every video will reach to you as soon as possible. Thank you.